Right. So we were dealing with OSPF NBMA modes in which we saw non-broadcast. We did not configure non-broadcast. When I put OSPF on the frame relay running interface, the network type is by default non-broadcast. And this NBMA mode, non-broadcast, did not discover neighbor because it's a non-broadcast. No multicast is supported, no hollow packets can be sent. So we were configuring neighbors manually. And we saw the timers in the NBMA as 30 and 4 times of 30, which is 120. And there is a DR-BDR election in that, so it's well suitable for full mesh. Secondly, we move to another thing is all the participating routers need to be in same subnet. Here we see 10.0.0.1 on router 1, 10.0.0.2, 10.0.0.3, 10.0.0.4 on router 2, 3 and 4. We moved on to the next mode, NBMA mode, called point to multi-point. In point to multi-point, there is no DR-BDR and neighbors are dynamically discovered. There is no DR-BDR and neighbors are dynamically discovered. That's what we saw. So, what is that drawback there? See, everything looks good, like neighbors are dynamically discovered and there is no DR-BDR. All those things looks good, but it's a WAN environment. In a WAN environment, dynamic neighbor discovery is not secured. It's not safe. And there is no DR-BDR, that is good point. There is no DR-BDR. See, we don't have full mesh always. In point to multi-point, there is no DR-BDR, it is good. But forming neighbor dynamically, not good. Because it's WAN environment, insecure. Frame relay in the middle is not safe. People can sniff, decapsulate and see what is going on inside. All OSPF updates can be read. So, multicast forming dynamically neighbor is not safe. Then anyone will bring a router with that sniffed information, like they know the subnet to which you belong to, and they form neighbor and they start giving wrong route information, then that will spoil our network. So we need another one, but there is no other one in the industry standard NBMA mode. In Cisco we have. In Cisco we call it as point to multi-point. In point to multi-point, which we did as the last mode in the previous class, I hope you remember, we gave neighbor manually. I would like to show you that once. Show run interface serial 4/0. Here you can see we have configured point to multi-point non-broadcast. This is Cisco's. So what Cisco has done is the best of non-broadcast, which is neighbors are manually configured, and then the best of point to multi-point, which is no DR-BDR. These two put together, point to multi-point non-broadcast works. So Cisco's point to multi-point non-broadcast is the best of the first two. In the first one, the best thing is neighbors are manually configured. In the second one, the best is, can you answer?
The neighbors are dynamically discovered, sir.
Yeah.
And BDR, no DR BDR election.
அப்போ என்னத்துக்கு ஃபர்ஸ்ட் பாயிண்ட் கொஞ்சம் அப்படி உளறிட்டீங்க?
What is that? No DR BDR election.
See, the best of non-broadcast is neighbors are manually configured. That is best. Why we call this best? Because it's public. It's frame relay. Over frame relay, you are trying to form neighbor. It's NBMA. It's non-broadcast, meaning what? It's a big internet in the middle between R1, R2, R3, and R4. There is big insecure network. If neighbors are dynamically discovered, it is not safe.
Yes, sir.
Configuring neighbors manually is best. So the best of the first one is neighbors manually configured. The best of the second one, point to multi-point, is no DR-BDR election. So these two together is what the third one, point to multi-point, non-broadcast, which we have. So when I check now, show show IP OSPF neighbor, I can see that these all have formed the neighbor and full adjacent, but there is no DR BDR. And also we configured these neighbors manually. Let me show you that. Show run section router OSPF. You see, the neighbors are manually configured. Now we are moving on to the third one. For that, what I'll do is I'll remove the OSPF from all the routers. And I'll do it fresh. When we do alteration, it takes really long time to fix things. So better remove and put it. Okay. So we have removed OSPF from router 4 and from router 3 and from router 2 and also from router 1. I also want to go check the interface. What if there is something in an interface? Show run interface serial /0. If any OSPF configuration, see, this is still there.
Yes, we have.
Let's remove this one also. And one last router. Then now what is next is we have to configure OSPF fresh from the beginning. I'll start from router 4 itself. Interface serial 4/0 IP OSPF network type. Okay, before that IP OSPF 1 area 0 IP OSPF network type broadcast. I'm making it as broadcast. Remember, there is going to be a DR-BDR election.
Yes.
And also, we need to make sure that it is fully mesh. It's not really fully mesh. If you want to go for this, you need to make sure you have full mesh before you do that. But it is okay. We are in the lab environment. We'll do it, but we cannot get reachability. That's the drawback because we don't have full mesh. Okay. I'm just telling the condition. If you are enabling network type broadcast, there is going to be DR-BDR, DR-BDR, and there is expected. It is expected to have full mesh. That is what I want to say. All right, now I'm going to paste the same thing on the other 3 routers. Show run to show history. Okay. We can see neighbor with router 4 is full state because router 4 is a DR now. Show IP OSPF neighbor. Okay, we can see router 3 is BDR, router 4 is DR, and router 2 is DR other. Yeah. So we learned that this is of no use actually, this DR BDR. If router 1 goes down, the relationship between 2, 3, and 4 will not be there. Router 1 is the reason for 2, 3, 4 participating in this election. If router 1 is discarded, all those 3 routers will be an individual router. They cannot form neighbor. Hub, router 1 is the hub. If hub is not there, how can they will be called as spokes? No. So that's the drawback. You cannot do this one if you have partial mesh. Okay, let's assume you have full mesh and you have enabled broadcast. What do you see here? Neighbors are dynamically discovered. And the timers are no more 40 and 120. I'll show you. Show IP OSPF interface serial 4/0. I can show you the timer here is just 10 and 40. See, if you want these advantages, you want the neighbor to be dynamically discovered, you want the BDR election, you want the timer to be 10 and 40, among this all same subnet members, then you can go for this network type called broadcast in a non-broadcast environment. In a non-broadcast environment, you are now having the experience of broadcast. Okay, next. We will check the routes. Show IP route, OSPF. See, there is no route because the DR is on router 4. Go to router 4, show IP route, OSPF. So we need to somehow make R1 as a DR so that at least few networks can be seen, or you need to make full mesh. Let me do full mesh. Full mesh is the suitable topology for broadcast. Now only from port number 1 of, see this number 1, this is 1 here actually. 1 is forming tunnel with 2, 3 and 4. Likewise I have to form tunnel from 2 to 4 and 2 to 3 and 3 to 2 and 3 to 4. That will form full mesh. Let me do that. Port number 2, two zero one to port number 3, 203. Add. Likewise, port number 2, wait, I'll zoom it for you. I think you may be. Is this possible to zoom? No. I'm not able to zoom this.
It's okay, sir. Fine, sir. So we are doing this in the frame relay switch only now, sir.
Yeah, frame relay switch. It's not so important. Two zero one to 204. Yeah. What is this? Okay, I need to put another PVC. It didn't allow me, no? Mapping already defined. Okay, then I need to give another number. 204 to 402. Add. The previous one I want to remove. It's okay. I think at least I can alter this. 203 302. Okay, likewise. Three 304 4 403. Port requirement. Let's see. Show IP OSPF neighbor. Okay. What now I need to do is I need to remove the static frame relay maps that I wrote. Because we have PVCs now, it will discover by itself. Likewise, I'll go to router 3 and remove. Okay, here I did not do anything related to frame relay static route. Okay, now let me shut down this also, and then unshut. Frame relay is full mesh. I'm expecting frame relay map. Show frame relay map. Still not yet. It will come. We need to wait. Show frame relay map. Not yet. See here 2 has come automatically, dynamically. We did not give. Similarly, all will come. Show frame relay map. Look at this, all 3 has come. Full mesh. This is what called as full mesh. Now because you have full mesh, you will have DR effective used. Show IP route OSPF. Still routes are not learned. Let's wait for that. Show IP OSPF neighbor. Here we can see router 3 is a DR. Router 3 show IP OSPF neighbor. Okay, router 1 is the BDR. I don't see neighbor with the router 4 yet. Show IP OSPF neighbor. Noted. I think there is a confusion going on. You see, for 10002, it is taking 401. No, it should take 402. I gave 402 here. Yes, I have given. I think this frame rate which is not really up to the mark. It should have taken full mesh, but it is still saying I am going via hub, which is not correct. Show frame relay map. This is good. To 1 it goes via 301, 302, 304. This is cool. This is cool. Show IP route OSPF, but no routes logged. This is also good. Why router 4 only makes that mistake? I don't know. Because of 4 everything is truck. all goes to 401. No, that's not the correct one. It should go. What statica? That is the problem. No, I think I have not removed from here. Show run interface. Serial 4/0. So that is the reason for this problem here. I have to remove this. I thought I removed this. Show frame relay map. Now it is correct. 401, 402, 403. Dynamic. Perfect. Show IP route OSPF. Okay, why the routes are not coming? Okay, we did not advertise. We did not, this OSPF we removed, no? So we are putting back again IP OSPF 1 area 0. I have to do this on all other routers to show history. Router 3. Router 2. And router 1. Okay, now you can expect reachability as well as routes. Show IP route OSPF. You got. Wait some time. IP OSPF 1 area 0. I think even on serial interface I did not enable. Now only enable it. Interface serial 4/0 IP OSPF 1 area 0. I'm enabling OSPF now. I thought I enabled earlier. After removing we did not put. We were only focusing on frame only.
Yes, sir, our interface speaking.
Okay, now it is done. We will see OSPF neighbor first and then only comes the network. Show IP OSPF neighbor. Router 3 is DR, router 2 is here or there, where is router 4? Show IP protocol. OSPF is running serial. Show IP OSPF. No neighbors. Frame relay is enabled, IP address is given, OSPF is enabled. The network type broadcast is not assigned. Interface serial 4/0 IP OSPF network type broadcast. Now you see the neighbors come. Okay, see I got all the routes. And what about router 1? All the routes. now you can see because it is full mesh, it is not going to the hub. If router 2 wants to reach 3333, it can go straight to 10003. It is not sent to 10001. It's not going to hub
Yes.
because of full mesh. So let us try pinging 4.4.4.4 with a source of 2.2.2.2. We are able to ping it. Okay, this is broadcast. Same like broadcast, you will have hello traffic, hello packets coming every 10 seconds. Let me show you that. Show IP OSPF neighbor. You see the timer here. Let's see only for this neighbor. 333, 34, 38, 37, 36, 35, 33, 32, 31, 39. After 31, again it went to 39, which means every 10 seconds the hello packet is coming. Alright, now what we go next is the point to point. The difference between this and the point to point should have only 2 points. Router 1 and router 2. Router 1 and router 3. Router 1 and router 4, which means what? They're all going to be different subnets. Then how I'm going to have 3 subnets here, I'm going to create sub-interface. Yeah, this one I'll assign to sub-interface dot 1. And then serial 4/0 dot 2 dot 2 I'll give 20.0.0.1/8, and then serial 4/0 dot 3 30.0.0.1 I'm going to give. And on the other side, this is going to be, I let it be 4, but this is going to be 30 here. And this is going to be 20. And this as usual, no problem. So, multiple subnets. 10, 20 and 30, multiple networks, different networks. Okay, let's do this. As before, I'm going to remove OSPF from all the routers. So we use this command to remove OSPF from all the routers. Do the same on router 2. Router 3. Router 4. Done. Now, let's start. As I said, router 1 needs to have 3 subnets. Interface serial 4/0, I remove the IP address, no IP address, because we are going to use subinterface. Interface serial 4/0 dot 1, point to point we have to say, and then I need to give IP address 10.0.0.1.255.0.0.0, and then I have to write, next, interface serial 4/0 dot 2, point to point, IP address 20.0.0.2, sorry, 2.1.255.0.0.0, interface serial 4/0 dot 3, point to point, IP address 30.0.0.1, 30.0.1.255.0.0.0. Now frame relay you don't need to do again and again for sub-interface, because under the physical interface we have already done. That I can show you. Show run interface serial /0. That frame relay is still there. That should be there, but no IP address in the physical interface. We give IP address to the sub-interface. Show IP interface brief, you can see those sub-interfaces. But when I say no shutdown to the physical interface, all this will come up. I don't want to say now. Let's finish on the other side. Router 2, there is no change needed. Router 3, we need to change the IP address. Interface serial /0. IP address is 20.0.0.3. And router 4, interface serial /0. IP address 30.0.0.4. So when I give this IP address, it will override the previous one. Previous IP address will be overwritten with this. Now we are going to put OSPF using Notepad again. Interface serial, before that interface loop at 0, IP OSPF 1 area 0. Interface serial /0, this is for router 2. I'll say IP OSPF 1 area 0, IP OSPF network type point to point. Yeah, then I say no shutdown. This goes on 2, 3 and 4. 2, 3 and 4 don't have any sub-interface. Alright, on 4 it is done. 3 also it is done. 2 also it is done. Now on the router 1 we have sub-interface. Okay, so this is going to be repeated 3 times, 2 more times. Router 1. Okay, so next is show IP OSPF interface brief. See, OSPF is running on all the serial interface as well as the loopback. Now let us check the frame relay. Only after frame relay the neighbor will come. See, the frame relay map is missing. The reason is this. We have sub-interface. On sub-interface, frame relay cannot discover, so we need to manually say this. Interface serial /0.1 frame relay interface DLC number. This is to go to router 2, so it is 102. Likewise, we go under subinterface 2, interface Delcy number 103. And then we go under subinterface 3, interface Delcy number 104. Now after this you will be able to see all the neighbors coming up. On the other side, no problem, that is physical interface side, they have no problem. Show frame relay map here. Okay, we have this configured and they're all active. Now going to router 2, show frame relay map. We have map and you see the newly added IP address is already discovered by frame relay, and I'm expecting similar thing on router 3 as well. Show frame relay map. Show IP OSPF neighbor. Okay, just got neighbor. It's point to point. You don't have a neighbor with everyone. So only with the hub. Show IP OSPF neighbor. Okay, great. Now in the routing table, you will be able to see all the routes. Show IP route. Look at this. All the routes.
Yes.
And source of. All right. So that's about point to point. And the timers are same like 10 and 20. You see here, show IP OSPF neighbor. You see the timer 38, 35, 34, 33, 32, 1, again 9, 39. So every 10 seconds the hello packets are coming. You can also see this in the command show IP OSPF interface serial /0, which we usually use, 10 and 40.
Yes.
And then the network type here is point to point. Even though it's not truly a point to point, it is via frame relay point to point. You get the experience of a real point to point over frame relay.